Hey guys, this is a video of basic examples of the substitution method and indefinite integrals. So if you're looking for like a complete guide of how this works, I have another video on that where I go through every single detail. Here, I'm just going to plow through a bunch of examples. So here are the examples that I'm going to go through. So I have this listed, so if there's a specific one that you want to see, you can just scrub through the video and find it. Or you can just use this as like a way to quiz yourself, and then you can kind of go through the video to look at any answers. So let's get started. So for this first one, so I have to determine what my u is. So my u in this case is going to be x squared plus 5. Now I take the derivative of this to get du, so that's going to be 2x dx. Now, two different ways that people do this. Personally, I'm fine with kind of leaving this like this because what I see as I look through the problem, here's my 2x, here's my dx, so I can substitute all of that for du. So I'll show you one way to do this and then I'll show you a second way. So if I make these substitutions, this is going to give me really, we'll call this u, instead of the square root of u, we'll call this u to the 1/2. And then the rest of this is du, so that would be the problem that I'd finish. Now, some people like to use another method, which is totally fine, where they solve for dx. So if I solve for dx, that would equal du over 2x. So the alternative way that you can approach this is, let's see, I'll just kind of do this over here. So I've got 2x times the square root of u, and then I'm going to replace this dx. I'll replace it with the gold, I guess. I'll replace dx with du over 2x. So some people prefer to go through the problem like this, and then they can see that they can cancel out those 2x's. And then ultimately what you're left with is the same thing, right? So you still get to this. So however you like to do the substitution is up to you. It's just really a thing of preference. So now I can just integrate. So let's see, this is u to the 3/2. Then I put the 2/3 in front here. And so then this will be 2/3. So now I replace my u, x squared plus 5 to the 3/2, all of that plus c. Don't forget the plus c. Okay, so moving on to the next one. So for this one, so my u is going to be probably the thing that's kind of encaptured by this square here. So let's see, my u in this case will be 3 plus the square root of x. Therefore, if I take the derivative of that, that's going to give me 1 over 2 times the square root of x dx. And so now, once again, I can see that part is captured here and here. So there's where my du will go. And then this part here, this is my u. So this will become 1 over u squared times du. That's really it. That's the whole way that that'll simplify. And if I want to write that with a negative exponent, it would look like this. So then this will equal negative u to the negative 1 plus c. So this is negative 1 over 3 plus the square root of x plus c. So that would be my final answer. Okay, so moving on to this next one. So notice here I've got sine squared 3x, and then I've got cosine of 3x. So probably the thing that's being squared, that's what I want to use to motivate my u. So my u in this case will just be sine of 3x, and then I'll just have u squared. That's what I'll replace this with. Therefore, my du is going to be 3 cosine of 3x dx. Remember, you're using the chain rule there. So now I'm going to have u squared du, because all of this, so this is what goes into this, so that's going to be squared. And then for my du, so it's all of this, so there's my 3, there's my cosine 3x dx, so I'm replacing that with my du. Again, one more time, if you want to see the scenario maybe where I solve for dx, so if I solve this for dx, that would be du over 3 cosine of 3x. So just to very quickly show you that one more time. So if I make these replacements, so I get 3, this is still my u squared, and then I leave the rest of the problem alone, so cosine of 3x, and now I replace my dx with du over 3 cosine 3x. So sorry, this is getting a little squished here, but you can see the 3's will cancel out. So this 3 will cancel out, and this 3 will cancel out, and then cosine of 3x and cosine of 3x, those will both cancel out, so I'm just left with the du. So it gives me this problem here. So however you want to think about it is totally fine. So this is 1/3 u to the 3rd plus c, And then I replace my u, so this becomes 1/3 sine to the third of 3x plus c. And now for the last one. So here, my u is going to be 3 plus 1 over x. Therefore, my du will be, let's see, this will be negative 1 over x squared dx. So all of that actually gets replaced perfectly. So there's my du, so there's the substitution there. And then here's my u. So this will turn into u to the 1/2 du. So very similar to one we just saw, right? So this will end up being, let's see, this is u to the 3/2, so then I need to multiply this by 2/3 plus c. And now I just replace my u, so this becomes 2/3 times 3 plus 1 over x to the 3/2 plus c. So there's my final answer. Okay, so those were all just basic examples, just to show you just a couple more of how to plow through them. No manipulations required. If you're looking for some manipulations or really tough ones, I have videos on that as well. I have both an overview and just straight up example videos, so pick your poison. Hopefully I'll see you guys next time.